we have deduced an expression for the torque acting on a current carrying loop placed in a magnetic field. B is tau equals to BIA sin theta. That was the expression, right? Where I is the current flowing through the loop, A is the area of the loop, and theta is the angle between the magnetic field strength B and normal to the plane of the loop. Now, let us assume a circular current, and current is flowing in, let us say, clockwise direction, right? Let us say clockwise direction. Current I is flowing through this circular loop. Now, this expression for torque can be expressed as vector quantity of the magnetic moment of the coil and the magnetic field. If a circular coil or circular oil carry current in clockwise direction, as is the case, then direction of magnetic field will be such that this circular current produces a magnetic field, right? And the direction of the magnetic field will be such that if we see from the lower side, then we can see that it is an anti-clockwise direction. So, in this side, there will be north pole, right? The loop will act as north pole, and from the other side, see here, clockwise, then in this side, there will be produces a south pole. From this side, the current is in clockwise direction, so the loop will act as south pole. Thus, a current loop behaves as a magnetic dipole. And if we define the magnetic moment of the current M is equal to I into A, then this term can be replaced by M cross B, and which is analogous to what? Electrostatic result. Clear? See here, this is the magnetic dipole moment. M is the magnetic dipole moment, which is the product of current flowing through the loop and the area vector. Clear? And from here you can get the direction of the magnetic moment also. It is the area vector. Now see here, we have already told that in this side you get the south pole, and in this side you get the north pole, and this circular loop behaves like a magnetic dipole. And direction of the dipole moment is from south pole to north pole, that is in the downward direction. Or if it is in the plane of the loop, then it will be into the board. Now, area vector also same, just go through this area in the direction of the loop current, then the screw advances in the lower direction, so that is the direction of the magnetic dipole moment. Dimension of magnetic moment, this is magnetic moment, right, is I into L square, right, or L square I, what you can say, L square I is the dimension, because I is I and A is L square. So the SI unit is ampere into meter square. Ampere into meter square is the SI unit of the magnetic moment.